Okay. So I hope everyone can hear me okay. My colleague in marketing, Louise, has just sent the information out across the chat feature. If there is any problems at all with the audio, you can use that chat window. At the moment, the lines are unmuted, but we will unmute the lines later to have a Q&A series at the end. We're scheduled to run for about 30 minutes. I'll do my best to keep to that, but as I say, we're happy to take questions over the chat window as well. Okay, so we'll dive straight into the topics, and I want to start just by talking very generally. Virtualization has become a topic of huge relevance across our industry right now. It's fair to say that a good few years back it was virtually not being talked about, if you'll excuse the pun. Now we see it cropping up all the time, and it's very, very relevant. But we do find there's huge levels of understanding and variances within that. So we'll start right at the beginning and talk a little bit about what it is, how it works, and why, which takes me straight into the benefits of it. Within that, we think that there are some specific elements that if you're an industrial user might be particularly relevant, so I'll look to cover those, and then take us on really to try and understand some of the issues that are associated with that. I'll then go on to talk about Stratus Everrun, which is one of the products that we use to provide virtualized systems within the sort of control systems arena, and we'll talk a little bit about some sort of situations and some sample customers. And that should probably be enough to get us for half an hour, and as I say, I plan to do some Q&A at the end as well. Okay. Okay, so we'll dive straight in. We'll start with the concept and ask the question, well, what is a virtual machine? Now, I really like this diagram because I think it's a really good way of explaining exactly what a hypervisor is and how it works. And for those who aren't aware, it's essentially, a container that allows an entire computer, or what used to be a physical machine, to exist and run as if it were a physical computer on its own. So, in terms of behavior, in terms of what you can do with that machine, it will behave exactly like a physical one. It has an operating system. It has the ability to run applications. It has the ability to be managed, but it doesn't have any hardware pieces in it at all. It's a step removed, if you like. And if you look at the diagram, you talk about that new layer of software, which is what we would talk about as a hypervisor, and it's that allows us to sort of take control of these as individual software containers. So those virtual machines that you create, they're going to rely very heavily on the hardware resources that are made available to it within the host, which is typically a machine or a group of machines that are then brought together collectively so that you can manage the virtual applications that you want to run. Now, fundamentally, what's happening here, I think the diagram explains it very well, is we are achieving an abstract level of abstraction. So the hardware and the software are not as closely tied anymore. You have the ability to move those virtual machines around and put them in different places. And fundamentally, that ability to manipulate entire machines and treat them as simply a piece of software or a saved file delivers an inherent level of flexibility. And fundamentally, that really is at the heart of what drives the benefits of using this kind of technology, in our opinion. Now, we can talk a little bit about history, and I won't talk about this for too long, but if you go back as far as the 60s and talk about mainframe computing, those kind of machines were constructed with some logical partitions that enable people to run multiple tasks or multiple threads of task. And doing that was a great way to improve utilization. And actually, it was very similar to what we're seeing today and an early precursor to it. Now, what's happened over time in the 80s and 90s is we saw rapid changes in terms of processing power and the costs associated with that. And so we saw a transition in that the processing power increased so much, it became fashionable to give every single user more resources and allow them to run all of everything themselves. As time's gone on, and we get towards the late 90s, and of course there's been an absolute explosion in the number of users and machines that you can find, and reached the point where, as processor and memory powers continue to improve, that virtualization's actually come full circle in a way almost, and become a viable strategy again for cost reduction, because there's so much power available now in today's processors and CPUs, and many of you will have machines that run important tasks and maybe only run at 10 or 20% of the CPU and the other resources that are available in the machine. So you can see how we're getting to a point where actually virtualization again makes a lot of sense, because there's actually quite a lot of latent power that's unused in a lot of machines that are sat installed today. And we can go back to 1999 for when VMware released the first virtualization product. Many of you, indeed I'm sure all of you, will be very familiar with the name, an absolute powerhouse of the industry, and you know, grown and developed hugely over the period since 1999 when the first products were released. You go back to 2005, so we're talking over 10 years ago now, when CPUs and processors were actually being directly developed and produced with virtualization in mind, and a big part of that development, of course, was the multi-core and hyper-threading technologies that we see in virtualization today. And you see down the bottom there, I've listed some of the main sort of players in this. VMware is probably the one that you all know the most, but increasingly Microsoft Hyper-V, again, becoming increasingly relevant. I think Microsoft's decision to put that technology into Microsoft Server and make it available to users as part of their package has gone a long way towards commoditizing the sort of hypervisor landscape. There's a number of different players that sit behind the big two, so Citrix Zen Server is a common name, and increasingly KVM hypervisor, which is what we'll be talking about a little bit today, as it's what underpins the Everrun product that we're going to talk about. And KVM, as it stands for Kernel Virtual Machine, it's come from the CentOS background, and it's based on the Linux open source hypervisor, so that's open source code that's becoming increasingly used as well. And that in a way represents a real shift. But I'll talk a little bit more about that as we go on. What I want to do first is try and talk a little bit about some of the advantages, some of the benefits. You know, why is this technology become so prevalent? And I'm sure most of you will come with me and agree that what we've seen in the sort of previous 10, 15 years is an absolute rollout of this technology across corporate IT. And there's a number of reasons why they've done that, and I can try to expand on that a little bit here. But the starting point comes back to what I was just saying about utilization and latent power. There is a real benefit and potential to significantly reduce cost and make the absolute most usage out of the hardware purchases you've already made if you're able to implement virtualization, because the way we can sort of consolidate resources and get the most out of those machines and very closely monitor how hard they're working and work them as hard as that and no harder, is very, very useful. And that brings knock-on benefits such as reduction in energy, reduction in the physical number of machines that you have to maintain, and also a potential extension in the life cycle, because you're now not so tied to the hardware. That fundamental point I made about abstraction will crop up time and time again in terms of delivering benefits, and certainly life cycle extension is one of them, because it's very easy to move that virtual machine and put it on another piece of hardware and yet get the same behavior. Now, talked about flexibility, and certainly that again is a key reason why corporate IT have pushed this, because what it's done is completely changed their ability to manage the architecture. And when I say manage, I mean what IT companies do, departments do, which is deploy things and manage them and keep them up to date. But also it's the ability to make changes quickly, be able to rapidly deploy or bring on new machines, whether that's in relation to a problem, or because the business has changed, or because it's part of disaster resilience. And all of that flexibility, again, comes in here and becomes incredibly useful. The ability to sit somewhere centrally and take control of the entire architecture, make changes that can automatically propagate across, is very, very powerful. And has kind of come hand in hand with a drive towards building up corporate standard libraries, which, again, if you're a big organization, you've got multiple sites, there's a huge amount of value in being able to reuse some of that work. In terms of support, it certainly changes or increases the ability to provide that. Virtual desktops and thin clients have exploded out into the market as a result of this technology. The ability really to reduce the maintenance significantly is probably one of, if not the number one benefit. Certainly in terms of our customers and the conversations we have, people are looking to significantly reduce their maintenance overhead if they can, especially with industrial and legacy systems, because it's a challenge. Virtualization and the flexibility it brings potentially gives some real advantages there. And certainly once you've gone to virtual, you're then in a position where it's more straightforward to actually do things like backup and failover and disaster resilience, as we'll talk a little bit more about today a bit further on. We talked a little bit there about IT, and we can talk about this from an operational perspective as well. Why have operations people seen benefits from virtualization in businesses with lots of IT? Well, because they care a great deal about business continuity. It's absolutely critical that the systems that are running the key parts of the business are always available when required, as the business demands. So, the concept high availability, fault tolerance become far more prevalent here, because we need to be able to manage a failure. So we can talk about high availability. We can talk even better about fault tolerance, which is what I will be doing a little bit further when we talk about the Stratus. But also from a DR perspective, from a backup policy perspective, virtualization is a technology that makes it much easier to achieve a higher level of business continuity. Again, operations, just like IT, will see cost benefits, because the physical footprint that they have to maintain may well be significantly reduced. Not only that, but utilising machines at 50, 60, 70% of their power rather than 10 gives a far better return on capital investment, keeps the money people happy. And certainly in terms of actual failures, the mean time to repair, you would hope, is significantly reduced in this kind of environment. So you're closing the gap in terms of the amount of time that the system may actually be down if there was a major failure. In terms of support, I keep coming back to it because it just seems to be one of the biggest topics for us and our customers. But moving to the virtualization model quite often means that a thin client model will follow as well. There's lots of similarities between how thin client architectures or terminal services architectures and virtualization operate. They both provide the ability to abstract from hardware, provide centralized maintenance, provide greater levels of control and better use of resources. So they very much go hand in hand, and we've seen a huge sort of growth in the deployment of thin client technology, and very, very often within these kind of virtual environments. So we can talk a little bit about a wave with virtualization, and I would hope no one would dispute that. I certainly get very little challenge to that as I go out talking to people in the market. I think what's been interesting is that the wave has swept through standard IT to the point where you will find absolutely huge install base and examples of the technology being used. But what's interesting is the way that it's swept across industry over the last few years. So if we were to go back even 5 years, I can tell you that as a distributor, we would not be doing that much work within VMware and Hyper-V. Yes, there were some people, and indeed Wonderware moved quite quickly to make the products certified on both the Microsoft and the VMware platforms. But it's certainly, in the last 5 years, our business has been forced to transition with absolutely no choice but to develop and invest in the expertise to understand this, because the requirement from the market has been something quite to behold in truth. Alongside this, of course, we continue to see development and improvements in the hardware power that's available. Moore's law continues unabated. CPU power continues to grow and become more powerful, and interestingly, it's the cores now that we're seeing. So, the actual CPU speeds, arguably there's a little bit of a leveling off there, but the multiple cores and the hyper-threading technology that's available in CPUs is designed to work well with virtualization. It makes it easier to prioritize the resources and dish them out across multiple virtual machines that you want to run. That's crucial, because that improves the very sort of throughput and computing capacity that is possible when you're running multiple virtual machines at once. So huge sort of steps that have been made in CPU power, which are enabling very, very powerful systems to be created in these environments. From a memory perspective, it continues to be cheap, it continues to be very available, and it continues to be lots of it getting larger and larger, which again facilitates exactly the same thing. And certainly disks, again, go hand in hand with that. They get bigger, they get faster. The other thing that we are seeing now is that solid-state disks are becoming reaching perhaps a little bit of a tipping point in cost, and providing a really decent performance uplift on disks and speed that people are perhaps used to. So again, that's another change that we're starting to see, but there's no question that the continual march of processor and hardware compute power continues unrelented. And what that's doing is it's directly feeding into the use of virtualization, and you can see here we're significantly growing and growing every year in terms of the number of virtual machines that are actually running in the world. And this is designed to, this information is meant to represent the entire world. So we look at today, 2016, and we suggest that almost 81% of the entire x86 workloads that exist in the whole world are running within virtual machine environment. So that tells you that this technology has absolutely revolutionized the face of IT, and there's no question it's starting to do exactly the same in the industrial control space. Now we can talk a little bit about industry, and there are some reasons I think that some of the things I've talked about become really relevant if you're an industrial user. If you're setting up new machines, if you're commissioning, the ability to do that quickly and with flexibility is very, very useful. Many of you will be familiar with the concept of snapshotting, which is the ability to basically take a picture or take a snapshot, as it says, of a given moment in time within a system, which provides you the ability to go back to that should there be a failure or a critical problem. Something that's very, very attractive and very, very interesting if you're an industrial user and you've got a critical system and you know that you're going to potentially have a problem and you know that you've got the ability to go back to a last known good configuration. Certainly also with industrial systems, virtually everyone I've been involved with has changed during its life. So that flexibility and scalability that virtualization brings, again, is a real asset to managing those kind of situations. And indeed, increasingly, we see people want to create testing and development sandbox environments to, work out gremlins within a system, or to give a chance to spread its wings before it's put into the real world. Virtualization again makes that very straightforward. So, taking that a little bit more about industry, these are really the areas where we're helping this. We're finding customers want to sort of use the technology for these kind of reasons. So top left, first one, consolidation. Many people would like to get away from maintaining many, many machines, especially if they're old sort of legacy machines, where maybe they're struggling with the parts and the pieces in there that actually need to keep the machines running safely. So the ability to consolidate multiple of them into newer hardware, but still run the old operating systems, is incredibly attractive. That brings a sort of legacy level of interest, which again is particularly relevant here because we know we're often dealing with systems that are a few years behind the time. From a lifecycle perspective, as I said, we can look to extend that. We can simplify the deployment of them by using virtual machines, and it provides a very easy step to things like DR test environments, as I've said. We talk a lot about thin clients here at SolutionsPT. It's not my intention to do that today, other than to say that our business is a bit like with virtual. It's absolutely swept through what we do. We find ourselves so much more involved in thin architectures now, and very, very often they go hand in hand with virtualized deployment. So, what does all this mean? Well, I want to talk a little bit about the technologies that are available to run virtualization. And your starting point is something like this: a standard server with some unmanaged components and a machine that essentially is at risk of having a failure if there's a damage to a single component or disk damage that could cause data loss. Now, we can take that a step further and we can look at things like clusters, which is where you probably add at least one other machine, potentially more, and then some networking and some software and some other elements to then control and manage a group of pieces of hardware and then run virtualization across them. And that's a very, very well-worn path in the IT world. It certainly adds a bit of complexity. It adds some extra cost. It requires some knowledge. And the other point that I would make is that a system like this will deal well with a failure. It will recover from it. It will bring the system back up. But it doesn't stop the issue from happening in the first place. And sometimes in a control environment, we care about that more than being able to necessarily just bring the service back up. We actually need it to never go away. I also like to put to bed one of the sort of myths that I hear, which is that people have got a virtualized system and therefore they've got a resilient one. It's not true. The virtualization environment can be complex, and it has to be designed correctly. It has to be designed with availability in mind to deliver a resilient virtualized system. If it's not designed correctly, or it's not optimized, or it doesn't have the right pieces in there, it actually become very difficult to maintain. And then the cloud, and I don't think anyone's suggesting that we're going to run control systems in the cloud today. Clearly, things like quality of service, connection, speeds, and so on. Big question around security still, I think, for the cloud industry. All those things are going to have to be resolved before people are going to start running critical control systems in the cloud, I would say. So there's a number of technologies there that can provide virtualization, but are they necessarily the right way to go about it for a control system? Some data here from the Aberdeen group. We talk a little bit about the cost of downtime. I think it's pretty self-explanatory there. The point is it continues to go up. The cost and the criticality of systems is continuing to be relevant for companies, and understanding this risk for yourself, understanding what the cost of your downtime is really the starting point when you're starting to architect a new system. Now we can talk a little bit about levels of resilience. Again, I hope this is fairly clear, but it really correlates to the diagram that I just put up. So a standard machine would be something that you could call level 0 because it doesn't have any redundancy. It's just a server that's vulnerable to single component failures. We can make that slightly better by having another machine in a cupboard somewhere ready to go if the first one goes away, and we'd call that cold standby. If we move on slightly to what's more commonly the sort of virtualization deployment, you'd see something like a HA or high availability system. And that will, as we said, have maybe 2 or 3 hosts. You'll run primary and perhaps failover systems within that kind of system. But what happens is if a system or virtual machine gets into trouble, the virtualization platform will start the service again on another machine, and it provides a way to ride out hardware faults. But it is waiting for a failure and then recovering and bringing the system back up. So the question you've got to ask yourself with a HA system is it going to come back up quickly enough, and is that downtime something that you can cope with? And we could go a step further than that, and we could talk about hot redundancy. We can actually put 2 systems in place that are completely synchronized. And that is close to what we can achieve with Everrun, but actually when we talk about Stratus, we deliver fault tolerance at 5 nines. And 5 nines means that we can reasonably expect to have less than 5 minutes downtime per year. And the only way to achieve that is to actually lockstep the hardware between 2 machines. So that's exactly what Stratus does to achieve the level of resilience that they do within the Everrun product, which is what I want to talk about now. So this is, giving us a comparison and introducing the Stratus technology. The Stratus technology is different to what you would see in standard IT, and it's there where the risk of failure or the cost of losing a device, or potentially there's something like human safety at risk. That's when the Stratus technology comes in. And you can see here from this brief summary, that the levels of downtime that we're aiming to achieve are, as close to 0 as possible, with no single points of failure existing at all within the system. So many of you will know the name Stratus. We talk about Stratus a great deal here. They're a very important part of what we do. We've been working with them for over sort of 15 years now, and they do deliver the highest levels of resilience that you can get in computing. So if you're looking to put a virtualized environment into, run something that's absolutely critical, the Stratus platform is a way to do that and take some of the risk and the complexity out that you might face if you try to implement it in a more mainstream IT approach. There's lots and lots of examples of where Stratus is used. I'll be more than happy to talk to you, anyone individually, about our successes, but some of these major ones here, right across emergency services, credit industries, banking, manufacturing, lots of places that you can expect to see these. And it's when things are critical. It's when critical systems or safety is at stake. Now, many of you will know Stratus, and you'll probably know a little bit about some of their history. If you go back as far as the sort of 80s and 90s, they've been ever prevalent in mainframe computing, and although that remains today, the business has transitioned. We've got, many of you will know about the Stratus FT server that's been around for a long time and is a very big part of what we do here. But as things have started to continue to move forward, Stratus have invested to deliver a software-defined availability platform as well. Because there are customers that don't want to use proprietary hardware. They want to be able to go and order their machines from Dell or from HP. And so software-defined availability is becoming increasingly relevant, and as Stratus move towards providing resilient cloud environments, which is very much in their sort of future roadmap, you can start to see the importance of having a software method of delivering resilience as well as a hardware one, which Stratus also continue to offer. And we will talk about that technology another day, but today I'm here to talk about Everrun. So we talk a little bit about consolidation. And as you can see from this very simple example, if you're running 3 machines on 3 servers, you do have some protection from risk if you lose one of them. Now, what we're saying is, if you're going to run a number of services or applications within the control system environment, the moment you virtualize, you open up yourself to a potential risk, and that risk is from consolidation, because now you're running multiple virtual machines in one place. And therefore, that hardware platform is now more critical than it was before, because you run the risk of losing all the virtual machines. So we talk about eggs in baskets, and we talk about the need for a strong basket that can actually cope with everything that you want to carry. So I'll introduce Stratus Everrun here, and we like to give it a comparison to VMware HA, because it's the sort of typical place that we get asked to sort of benchmark. And from our perspective, Everrun is a very valid alternative to using VMware for these reasons, really. It's about reducing the complexity, because our understanding is that a lot of our industrial customers, they don't necessarily have access to the same levels of IT expertise that they do in the main part of the business. And actually, the hours that they run and the times that they're going to need help mean anything they can do to reduce the complexity is we're told at least, is an advantage. So Everrun is a way to do that, but actually to do it using standard server technology. Now, I must apologise because that's a picture of an FT server in there, but to achieve this, you would be able to go and buy standard servers from HP or Dell. And interestingly, what you don't require is some of the larger pieces that are needed if you're going to implement a more traditional system. So we don't need external storage, we don't need storage arrays, we don't need VMware licenses, and we don't need multiple application licenses either. But I'll talk about this a little bit more as I go on. You can see here a little bit more into the architecture and how it works. So there are a number of sort of software layers within the Everrun product, but the way that you would build that up is to buy 2 standard machines and start by installing the virtualization platform and the Everrun applications on both of the machines. You then build them up, you create multiple links between them, and typically you'd end up with 4 different network links between all the machines, which provides multiple redundant paths. And then the Everrun software will provide the sort of mechanism to lockstep the 2 machines. So you'll end up with 2 pieces of hardware that are running and married in complete harmony. And then that environment is then maintained by Everrun, and into it you can create and deploy and run a number of virtual machines. And it's the virtual machine sitting in that layer above the sort of Everrun stack that provides the environment's resiliency, because it can actually ride now a complete hardware failure and continue running all the services that you've put into the environment. Now, the business is really built around the availability services, I would say. It's really designed for you to create an environment, put applications into it, and leave them there to run, which is what our customers continue to tell us is what they want to do. But the product does build on that to provide quite a few other features. Split site's particularly interesting. The ability to put those 2 servers in different places is particularly interesting to anyone who's worried about explosions or disaster risk. So we can certainly provide split site. I must make the point that you do need decent levels of network latency to achieve that, as I'm sure you can appreciate. For the systems to remain lockstep, they will need to have good network connections between them. But given that the network is up to it, it's perfectly possible to run these in different physical positions. We can talk about Watchdog. Many of you, if you've used the FT Server product, will know that the Stratus systems dial home and that they have a global network that's used for monitoring and notification. That remains the case here, and is absolutely something that can be used if desired. And I know there's questions around security for some people, and some people will never allow a dial out, but others will. And where possible, it provides an additional level of support and management. In terms of virtualization features, you can expect to see the majority of features that you'd find in a VMware or a Hyper-V. It's a built-in virtualization product, as I said, that's based on the KVM CentOS hypervisor, but it still provides the features that you'd expect in terms of snapshotting and virtual machine management and so on. In terms of storage, we do get asked about this, and it's an area where Stratus have invested in the products and improved it quite significantly in terms of storage groups and the way they're managed, the ability to actually add in additional external storage. We feel very much for our customers that the ability of not having to buy a SAN, not having to buy that external storage is a real advantage, but people who have already got it or have wanted to use it have asked a lot. Can that feature be added in? Stratus have added that. So it is possible, if desired, to use those devices with it as well. And ultimately what you get is a console that allows you to manage all of your critical systems and manage the virtual machines. That's what the acronym PVM means. It means protected virtual machines, because once the lockstepping is achieved and the virtual machines are running, they are then protected from hardware failures. We'll talk a little bit about some successes, and hopefully some of these are relevant to the kind of people that we have on the line today. We talk about Albion Sands in Canada. It's an all sands operation. They're producing lots and lots of oil a day. The cost of downtime for that system is staggeringly high. As such, they've invested in Everrun to protect that system. Everybody, I think, is pretty well aware of this pharmaceutical giant, and they've been using Everrun for a number of years now, again to protect a number of different critical systems. What's interesting is that some of the deployments that we've seen are not for Everrun. They're sometimes almost more IT type in terms of the type of applications. We've got plenty of people that are running Wonderware products or data historians or even batch systems, things like that. But equally, what people tend to find with Everrun is that there's a number of other systems that are important to people, and as they start to put these platforms in, they realise that there's other virtual machines that they would like to see protected, and they bring them into the environment, which is one of the things that's happened at Dumbia. They are one of the largest meat producers, feeding into many of the local largest supermarkets across the UK. Again, the criticality of their systems links directly to their stock management, their asset management, and has been a key part of what they do. I can't talk about who the customer is at the last one, but I thought it was worth putting in nonetheless, because there isn't many areas where safety is more critical than in nuclear energy, and again, the product's been deployed in that kind of environment to provide specialist protection for key systems. So where are you going to put this system? Well, interestingly for us, we as a company have perhaps lived exclusively at the edge in terms of applications that are put in places where they just absolutely have to run, but are not necessarily in a place where all the IT skill is permanently on hand. Certainly that's where we've played for many, many years, but increasingly we're starting to get asked about, can this go in a data center? Can we put this stuff in our data center? And absolutely, and indeed we're starting to see more and more of that as the continual presence of IT in the industrial world continues to, grow and have influence. So, in terms of Everrun, I hope I've given a little bit of an overview here. Essentially, it's a virtualization platform that's designed to provide the highest possible levels of availability and resilience with it, but do so in a piece of software that's hopefully simple to manage, doesn't require as much sort of technical understanding, as much equipment, and provides something that allows you guys to concentrate on doing what you do best, which is run your businesses and make your products, and let the IT stand on its own 2 feet. Okay, so we've not done bad for time there, we've just sort of made it on plan. I'll very briefly just talk about some of the upcoming webinars. We have a lot of interest in these, so I'm no doubt there'll be dates for your diaries. On the 25th of Feb, we will be talking about monitoring and securing your industrial IT infrastructure. And then I believe the same day in the afternoon, we're going to be going into the part 2 of today's webinar, where, having introduced Everrun, we're then going to go into it in much more depth. I'm actually going to have one of my good friends, Andy Bailey from Stratus, is going to come in for the day, and we're going to do that one together. And we'll be providing a more in-depth demonstration of the product, and I'll provide an opportunity for you to ask a lot more detailed technical questions of Andy, who will happily come in from Stratus to join us. You'll then be back with me again on the 24th of March, and I'll be talking about the evolution of mobile architectures, and a really interesting topic where we're seeing some really interesting products and some really interesting growth and changes in the market. So there are upcoming webinars, but I'm more than happy to open up the lines now for questions, if anybody has any. I believe my colleague unmute the lines. So if there are any questions, I'd be more than happy to take those if there's anybody now wants to ask. If there's not anybody jumping out to ask me a question, then I can make a start with a couple that we've been asked beforehand actually. One of the attendees had asked me about they're interested to understand about designing virtualized systems and making sure that they comply with some of the IEC requirements, and he's listed one of the regulations here. And it's very helpfully accepted that this might not be a question with a simple answer, because it will depend a little bit on the function of the system. I think the answer that we would give here is, come and talk to us. We're more than happy to get involved in specific detailed requirements that you might have in relation to projects that you do. And there's a wealth of resources and knowledge that I can tap into here to get answers to such questions. So I hope I'm probably not giving a full answer there, but I'm more than happy to address that, and would quite like whoever asked that question to sort of come into us and let us talk about it a little bit more. The other question that I'd asked about was compatibility with regards to hypervisors. And this is a reasonably common question with Everrun, and it's something that I'll be happy to try and address now, which is to be clear that vSphere is a VMware product, and that is not a product that you can use if you're using the Everrun product. Now, we will be talking about the Stratus FT server in a future webinar, and I'll be happy to go into lots of detail about how you can run VMware vSphere within one of those environments. But within the Stratus Everrun environment that we're talking about today, it is based on the KVM, the Kernel Virtual Machine Hypervisor, which is an open source hypervisor that's come from the Linux community, been developed over a number of years. And you know, you might be surprised to sort of see open source technology being at the heart of something like this. And yet, if you look at actually what's happening in the world at the moment, open source computing is growing year upon year, and the world's biggest operating system was recently confirmed as the Android operating system. So, good example of where open source has gone pretty well. And what Stratus have decided to do is use this technology at the heart of what they do, because it provides them with a level of simplicity and also flexibility in developing the product. Okay, we are getting some questions coming in on the chat as well, which is great. I'm more than happy to take those. So, okay, so we've got a question here around virtualization integration in relation to PCI cards. So, and this is a very good question, and it's a reasonably common one. So the question is, I've got some PCI cards, how can we integrate virtually? And in this case, we're talking about a PCI 33 megahertz card that's communication for a control system. This is a really interesting challenge, and it's probably a similar answer to the last one, in that I'd ask you to come and talk to us and investigate it with us. There's different examples and different ways that this can be handled. It really depends on what it is and how old it is, what kind of processes and so on. There are potentially some ways around this. Interestingly, I'm working on a project at the moment which is for one of the large infrastructure businesses, and they're currently upgrading, I think, 24, 25 sites that are all running legacy systems. And in this case, I think they're using something old like ControlNet, and they've got a similar problem to the one that you're outlining here, which is how do we maintain this level of comms when we migrate to new hardware? I'd like to ask that person that we'll get in touch and we'll discuss it directly with them, because if we understand a little bit more about what's going on, we might be able to offer some advice on how that can be done. Equally, there are times and there are situations where it isn't possible to virtualize for those reasons. And one of the things that we always have to really offer as a big caveat is that when you virtualize, there's a very good chance that if you put legacy systems into a hypervisor, they'll run. But what you should remember is that if those systems were built 15, 20 years ago, they were not designed with hypervisors in mind. So that performance is not necessarily going to be exactly what you expect. And certainly if you speak to any vendor for any legacy software that you find, and that includes Wonderware, anybody else for that matter, if you bring versions of the software that were developed long before hypervisors and then ask your vendor whether they're supported, they'll tell you that they're so old they can't make any promises about whether they'll work or not. And so for us, really, it's about looking and understanding where it's appropriate. Okay, I've got another question about from Andrew, which is in terms of the benefits of adding Everrun. It's a really good question. I think we find that it depends to a little bit of an extent on what the customer requirements are. Many of you will know that we've had lots and lots of success with the FT server for many, many years, and that remains the case. So where does Everrun come in? Well, for us, it's particularly interesting when customers have very clear views on what they want to do for their hardware. Because if they've got an agreement with somebody like Dell or HP, they're often in a position where they can purchase that at a significantly reduced rate, and so much so that to use anything else is just not sensible. So in that kind of scenario, Everrun's really attractive because they can go and procure a couple of servers through their IT, have them appear a couple of days after they've asked for them with very little cost for them to bear, and then they can go and buy a piece of software in Everrun, which is pretty attractively priced and provides a way to deliver really good resilience quite quickly and quite simply. That's one of the major benefits. I would say perhaps alongside it, one of the other ones would be simplicity, because you just don't need all the pieces that you need to run a typical VMware cluster. And that's attractive if you don't have a team of VMware qualified engineers that are available to, drop everything and come and fix your system in the middle of the night when you have a problem. So in terms of benefits, I would say they're two of the main ones. The third one probably is a bit of the functionality that I picked up on in the webinar, which is this ability to split the site. So again, if the IT network and the infrastructure is up to it, the ability to put those two pieces of hardware in different places is quite attractive if you've got a site that you're worried about possibly having an explosion or any kind of damaging events that could affect the stability of the equipment. We've also got a question with regards to Iconics, Genesis 64 SCADA. The simple answer is that I don't know for certain if it will, and you would have to check with Iconics. But what I can tell you is that if you have an application that will run in a server environment, a Microsoft server environment, or indeed a desktop environment, Windows 7 or whatever, as long as you can get it into a Windows operating system, you can put it into Everrun, and it should run. Now, I can only offer the should caveat simply because we haven't tested every piece of software in the world with the product. And that's what I think becomes really interesting here, is that because it's reasonably attractive in terms of cost and sort of simplicity, suddenly lots of different applications become candidates here for being protected, which makes things very attractive for some people. Okay, another really good question. So the question is regards to what case studies and information we have for virtualization in offshore control system environments. We do actually have some examples of that, and I actually think if I ask my colleague in marketing to get your contact details, I can send you through some information on where we've done some previous work ourselves actually in all, well, if it was gas actually, it was offshore in the North Sea. No, it's not in the North Sea, it's on the East Coast actually. But we do have. There's quite a lot of different case studies that I could potentially provide. I guess the question there would be whether is it technology-centric case study that you're looking for, or is it just virtualization-centric? Because there's quite a few different things that we've done in virtualization, whether it's with FT Server or whether it's with Everrun. But yes, I'm happy to take that as a request. I can definitely provide some good information on some work that we've done with virtualization for Wonderware systems, and I've got a couple of bits of collateral that I think you'll find quite interesting. I'll be happy to send those across. Okay, I think we've addressed most of the questions, and it's fantastic to get them, so thank you so much for asking. I'm more than happy to take any further requests on email. You know, we'd love the opportunity to speak to you guys more, if there's more that you want to learn. And of course, I look forward to being with you on the next webinar that we run. Thank you very much for your time this morning.